All right, welcome to another episode of Understanding Base 12 Math, How to Draw the Perfect Circle Using Dozenal Geometry. That's the title of my recently published book. You can access it on Amazon. You can also go to my website, which is at dozenalmath.com, and you can read some blogs that I've got there about Base 12 and Dozenal Math, and you also can buy some merchandise if you're interested in supporting me further. I've got some coffee mugs and t-shirts and some other things you can buy that would be greatly appreciated in terms of helping me to continue working on this. It's a lot of effort to put all this information together and present it in a way that is accessible to everyone. So I want to thank everybody who's bought the book so far, and I appreciate the comments that are coming in and the questions. So in this video, we're going to be talking about the square root of 2, or more generally, irrational numbers. But specifically the square root of 2, someone was asking me about that because we do build the diagram for 360 degrees that I present in the book in units of square root of 2. So how do we even access the square root of 2? So to access that length, square root of 2, we need a triangle, basically, or a square, where the sides are the length of 1. So we have a right angle triangle, sides the length of 1, and we apply the Pythagorean theorem, a squared plus b squared equals c squared. And when we do that, we have the two sides the length of 1, so 1 squared plus 1 squared is 2. So our hypotenuse, c squared, becomes 2. So c becomes the square root of 2. That's a number that when multiplied by itself equals 2. So we know that the base 12 Cartesian plane, or any Cartesian plane, is essentially a grid pattern. So all of those, larger squares and then smaller squares have the length of square root of 2 within its structure, going at a diagonal. So on the Cartesian plane in base 10, it's called the 45-degree line, and that's a degree line that is easily accessible, or it's easy to draw that line. It's very well defined. Every point on the x-axis has a corresponding point on that 45-degree line, or in base 12 it would be called the 3-9-degree line. Okay, I'm going to start using more Dozenal terms in the videos to come and introducing the correct numerals and the correct terms for Dozenal mathematics. I think we're going to have to really embrace these other ways of looking at base 12. Even saying base 12 is from a base 10 point of view. So a little bit confusing. Don't want to get off topic too much, but I do want to start introducing those ideas. So it's the 3-9-degree line, the same as the 45-degree line. That line is very well anchored on the Cartesian plane. And yet, when we try to define that length and say how long is the square root of 2, where does it land on the x-axis if we draw a circle, with that radius? What we find is that it seems to fall between the points that we're using to define our line, the x-axis. So that's how we get an irrational number, or why it's called irrational. It doesn't, that circumference of the circle isn't landing on a specific point on the x-axis. There's always a gap between the points on the x-axis and the point that's defined by the circumference of the circle. So often I've mentioned that to mathematicians. I say, hey, what about this remainder, this empty space? And that question usually gets a sort of a quizzical response, like, what empty space? There is no empty space. When we take that number to infinity, that space disappears. So we have to bring in the concept of infinity in order to somehow explain what's going on there. And so this is a problem for physics. And so this is something that I realized, is that this whole Dozenal math, base 12 geometry exploration actually has the prize that is emerging, which is the base 12 Cartesian plane and the pattern that we get from dividing the circle into 360 degrees, and the acknowledgement of the empty space that emerges from within that pattern. In the diagram for 360 degrees, we're literally dividing this the diameter of a circumference of a circle into its circumference, and then we're using the space between those sections that are to define where the lines of degrees go. And that empty space isn't just a small space at the end of a solid line, but it's dispersed throughout the circle. And so it's this ability to disperse the empty space, that remainder, throughout the circle, and then to increase it as the circle gets larger and larger, and the individual units of diameter are divided more and more, get smaller and smaller. This is the journey into the very small that occurs when we start to explore the matter that's all around us. When we go into the physical matter, we go into a world where there's a lot of empty space that is in between or surrounds the various components of matter, the electrons and protons and neutrons that we've discovered make up physical matter. There's a lot of empty space there as well. So this geometry gives us access to a structure that encompasses or has that empty space within it, and that doesn't exist in base 10. It's a different approach, and nobody that's looked at the geometric drawing that I've discovered has come up with any flaws within its design or the geometric structure. It's very balanced, it's perfectly symmetrical. It's only that it's a different way of approaching the circle that there's sort of a problem. And in the math world, there is no problem. There isn't considered to be any problem with regard to pi or irrational numbers. These are all considered to be finished topics. We know the numbers for pi. We have a model for pi. There's an explanation there, and so the idea of looking more closely or at a different way of approaching this idea seems almost blasphemous in a sense. The numbers for pi have been, in a way, put on a pedestal, and there's been posters made and books written, and there's a day for pi based on the numbers. So it's a very well grounded, a lot of structure and support for that number. It's very well anchored in our culture, and so when I come along and suggest there's a different way of looking at it, this is a laughable proposition. Nevertheless, this geometry does exist, and so the challenge is to get it to people who are willing to look at it. And this is the challenge I'm having right now, and I really feel that it's physicists who are familiar with math but are also open to a different way of approaching some of these familiar concepts, who are going to be the ones who are willing to explore this idea of base 12 geometry and the geometry of the circle that has been discovered and is being presented in this book. Okay, so I think I want to keep these videos pretty short, so that's basically it. I want you to feel like you can ask me any questions. I'm open to talking about any aspect of this geometry to anybody who's interested, because I really feel it's important to get the word out, to have conversations, questioning the assumptions that have been made already from a base 10 point of view, to acknowledge that there is a difference between base 10 and base 12, and to simply keep exploring. I use the term worthy of exploration a lot in the book, because I think that base 12 geometry is worthy of exploration, and it has a lot to offer, and there are new things there that don't exist in base 10. So that's the first hurdle to overcome, is that there is a difference between base 10 and base 12. So I hope that you are getting that from the book if you've already got the book and are reading it. If you haven't got it yet, I encourage you to buy the book, read through, and ask questions, and you'll then have more information to make decisions about the logic within base 12 geometry and what it is that I'm talking about, because I think a lot of assumptions are made very quickly when I'm saying there might be a different way to approach pi. It sounds like I'm saying pi is wrong. Base 10 pi isn't wrong within the structure of base 10, just like 1/3 isn't wrong when we figure it out to be 0.333 repeating forever. The mistake comes when we say, well, therefore a third cannot be, one can't be divided into thirds equally without a remainder. If you were to come to that conclusion, because 1/3 in base 10 equals 0.332, that would be the mistake. Because in base 12, 1/3 divided, 1/3 or 1 divided by 3 gives you the answer of 0.4, and that's it. So it's just one decimal place, and that's a different answer. That answer has different qualities than 0.3 repeating. So it is possible to divide 1 into thirds. You have to do it from a base 12 perspective. There's no remainder, so you get a different answer. So that same logic is what applies to pi. There's a different way of approaching it in base 12 that results in some different qualities of pi that are unavailable in base 10. So that's a simple way of saying it. So thanks for watching the video. Hope you can join me as we continue these base 12 book club videos. Yeah, thanks for watching.